Hello everyone. So I was just thinking about the alternators. I'm calling them alternators. They're lawnmower motors, electric lawnmower motors that have 3 wires. If you spin those and connect them to a full wave bridge rectifier that has 3 wire input and then 2 wire output for plus and minus, that's the way I plan to connect these, that I see it at the moment. An idea I was thinking about was, if we're running a motor and we use higher voltage, the motor will use less amps, and it's very responsive, very powerful. For example, if we use 25 volts going to the motor, it would use more amps to do the same work compared to if we were using 50 volts. That would use less amps to do the same work. Whatever that work may be, just the work matching each of those, or the load that the work the motor's doing. Okay, similarly, I was thinking, this is something I had thought about before, and then I was thinking about it today, and I'm going to work on this idea in the presence of sharing this with you. What I do not recall, because I've done this before where I've connected 4 alternators together in series. If I recall correctly, I had 4 alternators. Each alternator went into a full wave bridge rectifier, and at the moment I'm not recalling the way I wired it, but I think I had the bridge rectifiers connected together in series somehow. So let me try to visualize how I may have done that. Well, let's begin with the alternators. So if we have 4 alternators, or let's just say 3 right now, let's say 3, and then we have the bridge rectifiers. Now these will be larger full wave bridge rectifiers, because these are going to have 3 wire inputs. So these will have 3 wires. These are wires here. And then the output will just be a plus and a minus. So we can call these were motors, but now we're using them as generators. And more accurately, maybe an alternator, right? Because the magnets are probably north, south, north, south, north, south. And just the way it's wired, I think, would create an AC signal. But even if it was DC, if we put it into a full wave bridge rectifier, I think it would just be DC in and DC out. But if it's AC in, it'll be DC out when we're using a full wave bridge rectifier. And please confirm this for yourself. The terminology may not be perfectly accurate, but this is just experimentation. And I'm still learning the language of how to think about the words that describe the ideas. So if we run these in parallel, that would be just connecting, right? So if this is positive, negative, positive, negative, positive, negative. So parallel would add up the current, and the voltage would be the same. So at a given RPM, a given turns per minute, whatever that may be, if these produce a certain amount of power, a certain amount of volts and a certain amount of amps, we could add up the volts if we wire these in series, or we could add up the current, the amps. I'm trying at the moment, I'm going to try to remember how I wired these in series. So it may not have been wired this way, the way I did this here. See, before I was using a different kind of alternator. It was a lawnmower alternator. And I had these had 2 wires each on them. It was a John Deere alternators. And they were called, at the moment I'm not recalling what they were called. I know they were brushless. So these had 2 wires coming out. And let me think about how I may have wired this. So we have an AC. We have 2 AC input, right? AC input. And then we have a DC output. So we'll say plus and minus. And that's, all of these are the same. So AC. AC is for alternating current. And then DC for direct current. And DC is the kind of batteries that we're using. And then we'll just say plus, minus, plus, minus, plus, minus. Okay, let me think about how this may have been wired. I'm just wondering if what I did was, well, let me see, if I sent both of these wires in here and left the plus, let's say I left the plus. Let's see, if I connected the minus. Okay, let's try it this way. Let's say we connect the plus. If I connected this plus to the minus of this full wave bridge rectifier, and then this plus to the minus, and then this plus to the minus, and then this plus comes out. This is my minus, this is my plus. That may be how I did it. So at the moment I won't be able to verify that, because when I did this, I just was trying different ways of connecting it and then seeing what it did. Okay, and if I burned something out, I just replaced it because I was learning. Now based on that, it does look like I should be able to use that even with these 3-wire inputs, because it doesn't have anything to do, if what I said is accurate, then the inputs are still the same of each of these. It's just what I'm doing with the plus and the minus that changes. Okay. Now when we go in series, it's called series, what I was talking about here. When these are wired in series, it makes the voltage higher. So these will produce a higher voltage altogether. It'll be accumulated. So if these produce, let's say, 30 volts each, then if they're all in series, we can add that voltage. So 30, 60, 90, 120. 120 volts. DC. If I have a 54 volt battery, which is 48 volt nominal, but 54 volts fully charged, here's my thought. in a similar manner that it is more efficient, in my thoughts, I'm using my own words, to use higher voltage, because anything I say can be debated, but I'm just sharing what I'm thinking about, okay? I like high voltage. I like the responsiveness. I like the less heat. Now, if you increase the load, then it will run hotter and it can actually cause damage, yes, but if the load is similar to the lower voltage system, that's what I'm referring to when we're using motors, right? So now we're using generators and using these alternators, generators, energy pumps, right? We're using these to charge a battery in this instance. And what I'm wondering is, as a thought experiment, if I used, we'll start with this, 120 volts. Is that going to have less resistance? Two different tests. One test being keeping the battery fully charged. It's already full, and we just want to keep it charged while we use it. Let's say on an electric bike, right? The other test can be if the battery's drained halfway, and then we want to charge it up. But I'm primarily interested at the moment in keeping a battery charged. I want to see what that does, because it may take less work. There may be less resistance in just keeping a battery full rather than filling up a depleted battery. So instead of running the battery empty and then hooking up this system, if the battery's fully charged and then run this system just enough to keep it fully charged, maybe within 1 or 2 volts of being fully charged, or just keeping it fully charged but not overcharging it, I'm interested in seeing what that does. So we can expand on this idea and continue with if we say alternators in series, right? These are, the word was permanent magnet alternator. PMA, permanent magnet alternator. So a permanent magnet alternator, which is the John Deere alternators that I had been experimenting with years ago, had magnets in them, and then it had coils. Instead of like a car alternator, which doesn't usually have magnets in them, it has coils that are charged with electricity. So energy is put into the coils that cause a magnetic field, and it causes a north-south, north-south, north-south that spins past coils. Okay, and some experimentation has indicated that you can control how much energy, we can manually control how much energy we put into those coils, so we could turn that down to like 4 volts or just really low voltage and just see what happens when we spin it in an experiment like this, such as this kind. And I'm interested in that. But I would have to learn or talk with someone that could help me wire an alternator so that I can control how strong that magnetic field is inside there, the electromagnet. But today we're talking about permanent magnet alternators, PMA. Okay, so the lawnmower motors I'm referring to, I saw 2 different kind of motors in lawnmowers, which is I saw some that had brushes with 2 wires coming out. Something that was very interesting but rare is I saw it looked like what was happening was there was a motor that was, I'll call it a high voltage DC motor. So it plugged in, and then it had a full wave bridge rectifier just like these, like I was using, right? Because I've used full wave bridge rectifiers that are 50 amps, 250 volts. So it might have had a higher rating on the amperage possibly because these were lawnmowers. But there's different full wave bridge rectifiers. Now what I saw, this is unique, what I saw, it was unique to me, is these motors were pretty large, probably about this big, okay? And it had an extension cord, so you plug this into the wall, and it goes into a full wave bridge rectifier, and then from there, it goes to the motor. So the motor was powered by DC, but it was AC being converted into DC with a full wave bridge rectifier, which is very small, right? It's like this size, and that about this deep in a square like this, approximately. And that, if I recall correctly, that's all there was. And I think just an on and off switch. Now, it had really big coils and lots of copper and everything, but I was surprised at the simplicity of it. And it was interesting to see that it was a high voltage DC, in fact, 120 volts. I think we lose a volt or two, or a little bit of energy in the full wave bridge rectifier. But it was surprising to me to see that that could handle that much power going through it, if the power is going through it, right? Because where's the energy actually coming from, and where's it actually going? When we think about Thomas Bearden's lifetime research, and I mean a lifetime of collaborating with people that were of the highest education and study, lifetimes of study. And Thomas Bearden collected the masterpieces, the masterful, very concise understandings of many inventors and electrical engineers and mechanical engineers throughout the world. So let's go back to this one and see how this might be wired in series as well, since we're here. Now, similarly to this, as I had described, and I'm not sure this is the correct way to do it, but this may be how I did it, so we'll do it again. So on this side, we'll have the negative. This will be my negative, right? This is our negative wire. And this will be the positive. And I'm going to go over this. Okay, that means I'm going over the wire, right? So this positive is going to go over here to this negative, because that's how series works, right? But do not connect this just based on my description of this. Study to make sure this makes sense to you, and verify that this is safe to do. I'm sharing a thought experiment at this time. I'll take the plus and go over to the minus, and then this plus will go over to this minus. Yes, this is correct. This looks right to me. And then we end with a plus, see? And this is our minus over here. So this gives us the total voltage added of each of these. So that's when these are connected. So AC in, AC is alternating current. Okay, and then we're going to go into that. So these wires are going over, that's not touching, okay? And then here the same thing. So on each of these we'll connect here, and then we'll connect here. Now this is a thought experiment of, if we increase the voltage, would it be easier to charge the battery? Would it be easier to turn these, right, compared to if we run them in parallel? Well, the voltage, first of all, would have to be high enough. It would have to be a little bit higher than the battery voltage, right? So if this was only 30 volts and the battery's 54 volts fully charged, then two of these in series would give us a little bit more voltage than we need, right? 60 volts, if we need 54.5 volts fully charged for the lithium battery in the electric bike that I'm referring to for experimentation. And what I'm wondering is, if we keep going, if we keep adding the voltage, does it become more efficient? Does it continue to take less amps? Meaning, does it continue to have less resistance, right? Because amps is resistance, as I understand it. So in an extreme example, now we're just going here. So in an extreme example, what if I had, let's say, just as a thought experiment, if I had 600 volts, if I had 600 volts, and I turned these not at full speed, just very slowly, enough to bring the voltage of the battery up, sort of voltage started to climb, and watching temperature at all times. This is something I'm very interested in, to see what would happen. Now, of course, I'd have to be very careful, and I would research all aspects of this experiment thoroughly before attempting it. So here we'll do the same thing. So here we had the plus go to the minus, so we'll do that again. So we'll say here's our minus over here. We're going to connect this all together. These will be in series as well. Okay, so here's our minus. Minus will go over here. That's our minus. This is our plus. This is my plus. Go over that wire. And this plus will go over to this minus. And then this plus will go over to this minus, and then this plus will go over to, I guess we could say it can go over to the battery. I also have a choice of sending these wires into a capacitor. And the capacitor could be, that can be another experiment. It could be a higher voltage than the battery. There's a lot of different things that could be done over here. One idea is kind of like a strobe light, how when it reaches a certain, if I say potential, and then it dumps the charge and it flashes, it's similarly, maybe this positive and negative fills up a capacitor, and when it gets full, it dumps it into the battery, and it kind of sends pulses into the battery, pulses of voltage and current, right? Current first, because current is what comes through wires first, right? That's the first thing that shows up is current before voltage. That is what my research and study indicate. But what's important is, what is the battery voltage doing? So what is the minimum speed we can turn a lot of these, right? How many alternators can we have? And how can we have a very light load for them to do? Very, very little work. What's the least work by having many of these in series? It's a thought. Okay, everyone. Have a great day.